So for limiting reactant problems, the first thing that you want to do is write out your balanced chemical equation. So we have a problem here that says, suppose 13.7 grams of acetylene, which we did this was the carbide cannon that we shot the cloth out of and it hit the ceiling. Suppose that we've got this acetylene, otherwise known to you guys as dicarbon dihydrate. So dicarbon dihydrate would be dicarbon, so 2 carbon, dihydrate, 2 hydrogen. Okay, and we're going to suppose that this reacts with oxygen, which you know oxygen to be a diatom. Okay, if we look at this reaction, we can see that this is a hydrocarbon combustion. It's combustion because it's reacting with oxygen and a hydrocarbon, so all hydrocarbon combustion reactions produce carbon dioxide and water. Okay, so we're going to go ahead and balance this. We start with the carbon. We have 2, we have 1, so I put a 2. We go to the hydrogen. I have 2 and 2, I'm balanced. And now I have 4 plus 1 is 5 and only 2. So we know we have to go back and double everything because that's not going to work. So remember, we were looking for 5 oxygen. Remember that. That'll come up here in a second. We changed to 4 carbon. This becomes 4 carbon. Oops, sorry. 4 carbon. We doubled our hydrogen. This becomes a 2. So now 4 times 2 is 8 plus 2 is 10. 10 divided by 2 is, there's that 5 we were looking for. Okay, so we've got our balanced equation. Now we start the stoichiometry. So I have 13.7 grams of the acetylene, and I have 18.5 grams of the reactant oxygen. We have to take both of these over to one of our products, which question 1 says, what is the theoretical yield of carbon dioxide? So that's where I'm going to take it to. I want to know how many grams of this can be produced. So I'm going to do my 2 strike problems. So I have grams of acetylene to moles. I have moles of acetylene, and now I'm going to switch substances over to the carbon dioxide. So moles of carbon dioxide. You go one more time. Moles of CO2 to grams of CO2. I have to do the same thing for the other reactant to figure out which one is limiting and which one is excess. So I'm going to bring grams down of O2 to moles of O2. I'm going to go moles of O2 to moles of carbon dioxide. Remember, I told you guys before, the last step, that last little Tetris piece, is going to be exactly the same as up here. So moles of CO2 to grams of CO2, because we're going to the same place. Okay, now we fill in. So 1 mole equals our molar mass of this. So carbon is 12 times 2, there's 24, and hydrogen is 1 times 2, so there's 2. The molar mass for acetylene is 26 grams. Mole to mole. So I come up here and I have 2 moles of acetylene to 4 moles of carbon dioxide. And mole to gram, 1 mole equals the molar mass. Carbon's a 12, oxygen is 16 times 2, this is 32, you get 44. Okay, cross off my labels, and I should be left with grams of CO2, which is what I was looking for. So if you multiply your 13.7 times 4 times 44, hit equals, then divided by left parenthesis, 26 times 2, right parenthesis, that gives you 52, then hit equals, you should get 46.4 grams of CO2. All right, down here, we're going to do the same thing. So 1 mole is the molar mass of oxygen. And oxygen is 16, but there's 2 of them, so that gives me 32. Cross off my labels. Mole to mole. So I have 5 moles of oxygen and 4 moles of carbon dioxide. So that fills in there. And we know that 1 mole has a mass of 44 grams of carbon dioxide. Multiply 18.5 times 4 times 44 divided by left parenthesis 32 times 5 right parenthesis, and hit equals, and you get 20.4 grams of CO2. Okay, so now we've looked at this and we've seen that this is all that can be produced, and that's our 20.4 grams of CO2 is my theoretical yield, because theoretically that's the best I can do. I can't do this. I don't have enough oxygen to do that. I have enough acetylene, but not enough oxygen. Okay, that takes me right into question number 2. What's my limiting reactant? This is the limited product because of the oxygen reactant. So the limiting reactant was oxygen. That made the excess reactant the acetylene because he produced more. Okay. Next question says, what is the percent yield in the lab if 18.3 grams was obtained? So this is what you actually got. You actually got 18.3 grams in the lab. Theoretically, you were supposed to have 20 20.4 grams. So to find our percent yield, we're going to take our 18.3 divided by our 20.4 and then multiply that by 100. If I can get my calculator to work. Sorry, 18.3 divided by 20.4 multiplied by 100, I get 89.7% yield. So not bad for a lab, 89.7% yield. Okay, all right, that takes care of the first three questions. This last question, how much excess reactant is left over once the reaction has finished? So here's what I'm going to do. I'm going to just erase this bottom thing here. That's it. Okay, so we know that the acetylene was our excess reactant. So here's what I do. I start with the 20.4 grams of CO2 because this is what should have been produced. Okay, so now that I've got that there, I'm going to erase it here. I'm going to take that back to my excess reactant. So notice it's this problem just in reverse. So I'm going to go grams of CO2. Whoa, sorry. Stop. Here, hold them. Back. Okay, sorry. Grams of CO2. Okay, the thing does not like me today. There we go. All right. Moles of CO2. Moles of CO2 goes to moles of acetylene because that was our excess reactant. And then one more. Moles of acetylene goes to grams of acetylene. So here's what I mean by it's this top reaction reverse. Before, we went from the acetylene over to a product. Now we're going from our product over to how much acetylene we need. So grams to moles, 1 mole is 44 grams. It's just this step flipped. Moles of CO2, there was 4. There was 2 of acetylene. It's this step flipped. And then moles is 1 mole to 26 grams. So I'm going to multiply everything on top, and I have 20.4 times 2 times 26, and then I'm going to divide that by 44 times 4, and I'm going to do that in parentheses so I don't mess anything up. Okay, so I should end up with 6.03 grams of C2H2, which is used. Okay, because that's how much it would need. We started with 13.7. This is what we started with. So to figure out how much is left over, we subtract the 2. So 13.7 minus 6.03 equals 7.67. This is how much is left over. Okay. My suggestion, guys, as you're going through the practice, go through the problem, see what you get, check and see if your answers are right. But it doesn't hurt to watch this video a couple times and just stop the video, do the problem ahead of me, and then watch and see if you did it right. If I get a chance, I'll try to make another one for you, but hopefully this one helps for tomorrow's quiz.